I'm going to give a quick high-level overview of what you can do here with Dynamo. I've launched up the application. It's located in the Add-ins tab. I'm using it on Revit right now. I'm going to make a point. Not going to be any great shakes, but just this is what we do. So if I go and I look for a ref point, that's what I want to make. I get a ref point out here, but you notice I don't have anything out here yet. I'm going to run this automatically so I can get a little bit of feedback on what's going on here. So it says it wants a XYZ coordinate to be put into here. So I can either search in here for XYZ like I did before, or I can go and look in a sort of a logical place for it. I can look and create geometry, point, there's my XYZ. So the difference here is that I've got Revit geometry, and I've got sort of an abstracted geometry. These are Revit elements, and this is sort of general ideas of geometry. So I have an XYZ coordinate. It's giving me a red error system sign here because it needs a little bit more information. That is, it needs to know where the X and the Y and the Z are coming from. So if I go, it's going to give this a number. I can just drop in this number. But I also see I've got a slider. Everybody loves sliders. Sliders are fun. So I'm going to wire up one of those guys. So if I wire up a 0, I'm going to put this basically at 0, 0 on the XY axis, and then I'm going to have a slider hooked up to the Z. You can see now I've got my point. Now this point is a legitimate full bore Revit element. I can go in and I can draw some stuff that references it, and I can build other stuff off of it like that, and do some other stuff in the canvas, but it's still hooked up here to the rest of my definition. So I can move this around, and we can see that the rest of the geometry that I've made is moving around. So this all sort of seems like a lot of effort to put into just make a point, right? So let's do something a little bit more interesting, a little bit more complicated. So over here, you'll see I've got sort of a preliminary sort of building model. So I've got my box building, and then I've got some sort of skeleton of where my roof is going to be. So let's do something that's going to build that roof out. I'm going to open up another definition here, and this one's definitely more intensive, and I'm going to turn off run automatically so I can just set this one up. So right now what it has is I've got sort of a logic puzzle here that's going to take a couple of inputs, these curves, and it's going to assemble them into an ordered list of points and then put a truss system on it. So the first thing I need to do is I need to go in and get those curves into my definition here. So if I go select curve, I can, oops, the old tabbing there. I can get my curve instances and just drop them right into my definition. So now I've got 3 curves, and I can do something with them. So I'm going to put points along them, and then I'm going to slice them all. I'm going to sort of sew them all together with an adaptive component, which is, you know, a loaded family that's going to do something cool. So right over here, I've got a list of all the different kinds of adaptive components that I've got in this family, and I'm going to do sort of the simplest one here. And I'm going to run this thing. I'm going to run it automatically so that it just sort of keeps updating as we go along. You can see now it's gone. It's threaded those 3 together with what looks like some fairly simple lines, but do not be deceived. These are adaptive components. So that means it's a loaded family. It means I can swap it out for other things. This is just basically sort of a scaffolding geometry. But over here, you can see I've got my select family. I can pipe into it any old 3-point family that I want. So I've got a couple of other ones here. So let's say I want to go in and say, let's put in a square truss that I've got. It's going to percolate through, and you can see now I've got some more complex geometry. And again, this is all still hooked up to the rest of my network, so I can decide if maybe I want a wider spacing. You can see it updates. I can make it a little bit tighter, a little bit more dense in the structural system. And, you know, I can also just swap it out for other truss systems that I've got. I'll put in my wire truss, and it'll percolate through. And so I can get, you know, a couple of different, really different sort of variations on my roof form fairly easily. Now, I can also go in and I can recombine these things. I found there's a sort of a funny thing I could do here. changed around the wirings of these. It basically flipped around the geometry so that now I have my form twisting a little bit, which is, you know, sort of the wonder of discovery with these tools, is that you can come up with results that you weren't expecting. And sometimes it's what you're not expecting, and sometimes it's what you're looking for. So one other workflow I want to show here is using Vasari now. What I've got is I have a sort of early stage building massing model in an urban context, and it has a solar radiation analysis been applied to the ceiling, to the roof. And let's say that I want to put a photovoltaic array up on the roof, but I don't know quite what the right orientation is going to be to get the most out of that array. So what I've got here is I have a definition which is fairly simple. What it's doing is leveraging some intelligence in this family that allows it to rotate. And so basically I'm going to rotate this family through 180 degrees or 360 degrees, and I'm going to measure the solar radiation on the roof of it. And after it goes through and it measures each one of them, it's going to pick whichever one is the highest. So if I go and I start running this, you can see it's starting off at basically a 0 angle, and now it's incrementing through basically 12 increments of a 360 degree rotation. And after it's done with that rotation, it'll tabulate the results and say which one of those increments was the highest input of solar radiation, and then return that. So now I've popped back to that value. And now I've got my highest input, my optimized solar radiation. Anyway, this is a couple of things that you can do with Dynamo on top of Revit and Vasari, and I hope this was a little bit useful for you. Thanks.